Welcome to This Explainer. I'm your host, and today we're treating the Cambridge AS and A-Level Mathematics 9709 syllabus exactly like an esport, a game that can be perfectly, ruthlessly optimized. We're going to conduct a comprehensive exam strategy speedrun right here, right now. Our core objective? Maximizing your marks against the clock. We are going to completely overhaul your reading speeds, we'll deploy rapid analytical frameworks, and we are going to eliminate every single wasted action so you can conquer those high-tariff questions before that exam timer hits zero. We are specifically targeting Unit 2.3, Trigonometry Identities. Consider this your absolute insider's optimization guide to conquering the map layout of the exam paper and locking in that A-star grade velocity. Take a look at our master interface. We've got our active run timer going, our mark velocity tracker is live, measuring your marks per minute, and we are completely ready to break down the exact assessment objectives you need to secure top-tier marks. So I really have to ask you a serious question before we start the run. Why do top students, the ones who study the hardest, consistently lose marks on standard trigonometry questions? You know the formulas, right? You've done the homework, you've grinded the practice sets. Yet, if we look at the data, the Cambridge Principal Examiner reports tell us that candidates constantly bleed marks here. It's a massive performance leak. Well, I'm going to let you in on a little secret. The issue isn't rote memorization. Not at all. The secret lies entirely in execution. It's about avoiding hidden time sinks. In a high-pressure exam environment, getting the right answer just isn't enough anymore. You literally need to get the right answer efficiently. It's a race. Every single minute you waste wrestling with a suboptimal algebraic path or misinterpreting a Cambridge command word is a minute stolen from a heavier, high-tariff question at the very end of the paper. That causes an immediate drop in your grade potential. Today, we're going straight into the code to patch those exact performance leaks. Okay, let's dive into this. Here's the agenda, our route map for mastering this section. 1. Core trigonometric identities. 2. The method mark strategy. 3. The deconstruct, solve, evaluate loop. And 4, top examiner warnings. Let's get moving. Section 1, Core Trigonometric Identities. We are officially in Phase 1, dissecting the route metrics to give you the ultimate time saves. Look at the absolute simplicity of our core loadout here. Secant squared theta is identically equal to 1 plus tangent squared theta, and cosecant squared theta is identically equal to 1 plus cotangent squared theta. These are the foundational trigonometric relationships required for multi-stage analysis in Section 2.3. Let me be incredibly clear with you. This specific topic appears in every single examination series. It forms the absolute bedrock of our strategy. But here is where the time sink happens. Novice candidates look at a complex trigonometric proof on the map layout, and they instantly try to convert every single secant, tangent, cosecant, and cotangent into basic sines and cosines. That is a massive, massive time loss. It turns a quick, efficient 3-line proof into a brutal 10-minute algebra swamp where you're drowning in fractions. Your marks per minute literally drop to zero. The optimal route? It's recognizing the geometric structure of the equation instantly and deploying these specific Pythagorean identities like a frame-perfect combo. And this is exactly why the Cambridge Core Principles state something really crucial. They say the assessment framework prioritizes analytical depth over superficial breadth. What does that actually mean for your run? Examiners aren't looking to see if you can do 20 lines of basic fraction manipulation. They really don't care. They want to see if you can look at a tangled, messy trigonometric equation, spot the underlying structural framework, and execute a surgical strike using the precise identity. That analytical depth is exactly what separates a standard pass from an elite top-band performance. You aren't just plugging in numbers and hoping for the best. You are demonstrating true mathematical fluency and moving with purpose. Moving right along to Section 2, the method mark strategy. This is where we break down exactly how points are awarded, and we enter the co-op challenge arena. So let's head into the arena and look at our split-screen viewport. The crucial point here is understanding flawed execution versus optimal execution. We're tracking 2 players live right now. Player 1, let's call him Alex, is on the left. Player 2, Sam, is on the right. They are racing to clear this paragraph layout before their screen buffer locks out. Now look at Alex's strategy. Alex is slowing way down. He's writing out every single basic definition, spelling out every arithmetic step, aiming for absolute textbook perfection. He wants to outline basic definitions before doing any math. But look at his run clock. It's draining fast. He's detailing secondary evidence points that the mark scheme doesn't even require. That is a massive time loss. On the right side of the screen, we have Sam. Sam is a fast writer. Sam pushes to throw a high-velocity analytical thesis straight onto the page, skipping all the annotations, doing complex substitutions purely in her head. She drops the final answer on the page to maximize score acceleration. But wait, look at the mark velocity tracker. It just tanked. Why? Because Sam triggered marking penalties. She skipped the command word parameters. The question said, show clearly. And because she didn't show the process, a tiny mental math error cost her all the method marks. She scored a 0 for the whole section. So, what's the optimal execution? It's the perfect middle ground. You state your identity clearly, you substitute properly, you show the exact structural path. By doing this, you automatically lock in those checkpoint method marks, even if your final arithmetic fails at the very end. You protect your score.
Now, here is an absolute game changer for your strategy, directly from the meta. The theoretical architecture of the syllabus rests on precise definitions, absolutely, but also on integration with other syllabus areas. If you want to accelerate your score velocity, you need to reference cross-topic connections. For example, you might be running a standard trigonometry question and suddenly, boom, it secretly turns into a hidden quadratic equation in terms of tangent squared theta. This is where unprepared candidates freeze and lose their pacing. When that happens, you do not panic. You seamlessly shift your analytical framework into quadratic mode. You might even calculate the discriminant, b squared minus 4ac, to prove there are no real roots for that specific trigonometric function. Adapting your layout seamlessly like that shows the examiner you have absolute, top-tier mastery of the map layout.
All right, let's transition into Section 3, the deconstruct, solve, evaluate loop. This is the exact step-by-step procedural framework you need to speedrun these problems. Let's energetically walk through this rapid, error-reducing operational loop. Think of this as your ultimate time-saving combo. Step 1, the 60-second command word scan. Do not pick up your pen until you do this. Does the question say solve or prove? If it's prove, you are locked into working strictly from one side of the equation. You literally cannot move terms across the equal sign. Doing so instantly invalidates your run. Step 2, extract relevant data. Pull out the exact domain boundaries for theta. Is it 0 to pi or 0 to 2 pi? Step 3, select the analytical framework. Do you see squared terms in the equation? Immediately prime those secant squared or cosecant squared identities we talked about. Step 4, execute with clear notation. State the identity, substitute it in, and link it clearly to the next line. Step 5, present with correct terminology. Ensure your angles are in the required format. Exact values like pi over 3 or the specifically requested decimal places. If you miss the decimal place requirement, you drop a mark at the finish line, and we cannot afford that. Time split check. Okay, I am hitting the pause switch on the active run timer right here. Look directly at me. Before we execute this final top band paragraph and lock in an A-star grade velocity, you need to optimize your subscription feed. Subscribe to Ace the Exams, that's at Ace the Exams, right now, and turn on all notifications. Hear that bell ring? Hit it. No matter if you are running IGCS, O-levels, AS, or A-levels, this channel is your central tracking center to outpace the clock and fundamentally beat the examiners. All right, timer's back on. Let's hit the ground running. Our players Alex and Sam just hit a structural roadblock mid-paragraph. Their mathematical evidence just dropped out of alignment, and it's slowing down their mark tracking. They're trying to figure out how to structure a complex mathematical proof. This is where we step in and deploy a classic optimization template. You might think the Peel structure, point, evidence, explanation, link, is just for humanities essays. No way. We can adapt that logic right here to smoothly transition through mathematical arguments. Let's rewrite their text out loud line by line to create a pristine, high-scoring block. Point, state the trigonometric identity explicitly. Evidence, show the exact substitution into the equation. Explanation, execute the algebraic expansion without skipping lines. Link, tie the simplified expression back directly to the show that requirement. That is evaluative thinking in action. Top-tier candidates don't just solve blindly. They evaluate their evidence quality, they question their assumptions. For instance, did dividing by tangent theta inadvertently eliminate a valid solution? They justify decisions with evidence, and they check for reasonableness. If you calculate a principal angle and get a negative value when the context demands a positive physical length, your evaluative thinking should instantly flag a performance leak. Moving swiftly to Section 4, Top Examiner Warnings. This is the most critical intel we have, straight from the source. Examiner alert, listen to me very closely right now with intense focus because this is the ultimate optimization tip to prevent unnecessary point deductions. We are mining this directly from the Cambridge Principal Examiner reports. The data reveals that candidates consistently confuse cause and effect in their terminology and their working. You absolutely must explicitly show your working. Let's talk about show that questions.
In a show that question, the final answer is already given to you on the page. The examiner literally tells you the destination. Therefore, the entire point of the exercise, the absolute payload of the marks, is found entirely in your methodology. If you skip a logical algebraic step, even a small one, the examiner's rubric assumes you just worked backward from the given answer to fake it, and you will be severely penalized. You will lose the points. Never ever skip the structural cause that leads to your mathematical effect. You have to build a bridge piece by piece. And this brilliantly illustrates our interactive viewer time trial. I'm handing the controls over to you, the audience, right now. Look at these top 3 mistakes on the screen. Number 1, confusing cause and effect. Number 2, forgetting to check format and presentation. Number 3, answers are not specific to the given context. We are going to run Challenge 1, the 60-second trend extraction, mixed with Challenge 2, spot the performance leak. I'm flashing a flawed sample student paragraph on the screen. Let's run the timer. Imagine a student is executing a complex trigonometric solve. They do the math perfectly, frame perfect inputs. They isolate sine theta, they take the inverse, and they find the principal angle is 60 degrees. It looks beautiful, but then they just stop right there. They box the answer, they drop their pen, and they move on to the next question. All right, I'm using the digital highlighter right now. Spot the leak. Where exactly did they just lose 4 critical marks? I'll give you 3 seconds. 3, 2, 1. Time's up. Did you catch it? They missed mistake number 3, context. The question's given domain allowed angles all the way from 0 up to 360 degrees. By just stopping at 60 degrees, they completely forgot to check the second quadrant for the other valid angle. Sine is also positive in the second quadrant, meaning 180 minus 60 or 120 degrees was the second required answer. That bad pacing and lack of domain checking cost them top-tier marks. You must systematically check your answers against the given boundaries every single time. And with that, Alex and Sam have completed their final high-scoring response paragraph, and we get to watch their mark velocity tracker hit a glorious 100%. We have reached the victory screen, everyone. Let's distill this entire speedrun session into 3 universal optimization rules. Rule 1, the 60-second command word scan. Always, always know exactly what the question is asking before you pick up your pen. Are you solving or are you proving? Rule 2, the marks per minute budget allocation. Use that deconstruct solve evaluate loop we practiced to secure those method marks as efficiently as possible without getting bogged down in unnecessary definitions. Rule 3, the final 5-minute quality review pass. Verify your domains, check your quadrants, and ensure you haven't confused cause and effect in your show that questions. If you execute these steps, you will absolutely crush the clock. Now I have a final provocative question for you to close out the run. Which specific Cambridge unit framework do you personally find the hardest to clear under time pressure? Is it integration? Is it 3D vectors? Complex numbers? Let me know. Make sure you practice past paper questions using these precise speedrun techniques. And remember, subscribe to Ace the Exams at the handle Ace the Exams. Click that notification bell for weekly strategy tutorials, and drop a comment below sharing your answer to that question. I want to read what you find the hardest so we can tackle it next. I will see you in the next Masterclass Explainer. Keep your velocity high, optimize your runs, and good luck out there.